Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Habib bin Abdul Malik. This is our group members, and now we will be explaining to you guys about road safety audit. So, what is road safety audit or RSA? RSA is a systematic process in which an independent qualified team examines a road or traffic project to identify potential safety issues and suggest improvements. So, conducting RSA is very crucial because it helps prevent the accidents and injuries, improve road design, reduce costs by arising the issues early, ensures roads are safer for drivers, cyclists, and pedestrians. We have decided to conduct the road safety audit in this specific junction between College Perindu and College Delima due to one of the most problematic junctions in UiTM Shah Alam. Speeding. A lot of vehicles speeding from the road of the Delima intersection to the main road T junction. This can lead to a high chance of losing control of the vehicle to avoid obstacle or stop suddenly. In addition, it will endanger road users, especially the safety of pedestrians that are working on the side of the road. Alignment. Alignment can be separated into two categories, which is horizontal alignment as well as vertical alignment. For this specific road intersection that we have chosen, the problem with the horizontal alignment is the curve in the intersection is extremely sharp, almost resembling a 90-degree turn, which is a significant failure in terms of horizontal alignment. This sharp turn can be dangerous for drivers as it requires them to slow down abruptly and navigate the curve with precision. Cross-section. From the road safety audit that have been conducted, the problem that can be found in cross-section is the width of the entry lane to College Perindu is only 2.1 meter. Furthermore, this problem is not only seen for the entry lane to College Perindu but also to College Delima because the width of the entry lane to College Delima is only 3.1 meter. Visual aid. At the main T junction, road doesn't have a zebra crossing. There is a higher chance of collision between vehicle and pedestrian because the vehicle may have to stop suddenly if pedestrian cross randomly. Other issue is no directional arrow. Driver may slow down to find the correct lane or direction such as turning or merging point, causing a delays and congestion, especially during peak hours.
Assalamualaikum everyone. My name is Tuan Rafli Iman bin Tuan Azmi. The reason why we choose intersection between College Perindu and Archis for our RSA is because it was one of the most important intersection at UiTM Shah Alam. Okay, so now we will observe the situation of this intersection during the night time, whether the street light is functioning well or not. Assalamualaikum everyone.
So we found that the street lighting at the T junction during the night might have been functioning well, but in previous cases there have been street lighting that might be broken or not functioning well.
So the first experiment is spot speed study. This study aims to identify speeding behavior at the intersection where faded marking and lack of zebra crossing may lead to unsafe speed variation. It is also to evaluate whether the current road design encourages safe driving speed. So for the apparatus, is measuring wheel, radar gun and stopwatch. We use two methods, which is manual method and automatic radar gun method. First, two reference points are labeled as start and end point with a distance of 50 meters apart by using measuring wheel. Observer at starting point will give a sign to observer at the end point to record the vehicle time travel from start to end point by using a stopwatch. For radar gun method, position the radar gun directly aligned with the upcoming vehicles and should less suspicious to avoid influencing vehicle speeds. The data collected will be recorded in data analysis. For this road safety audit, we collected 100 speed data by using both manual and radar gun method. The average speed captured by the radar gun was 31.7 km per hour, while the manual method recorded 23.6 km per hour. This variation may reflect differences in equipment precision, positioning, and the data collection techniques, which is expected in field measurements. Moreover, the 85th percentile for radar gun is 33 km per hour and 38 km per hour for manual method, which means a portion of vehicles are still traveling at relatively high speed. During our site assessment, we observed faded road marking, limited signage, and the absence of zebra crossings, and these can lead to unsafe speed behavior. In conclusion, our finding shows that the current road design does not effectively encourage the driver to maintain a safe speed, and this is critical issue that should be addressed in the road safety audit.
Our second experiment, traffic volume study. In this road safety audit, we focus on traffic volume as a key factor affecting safety. High volume during peak hour can lead to congestion, which may cause driver to speed or take risks. By analyzing the cross-section, we can assess if the lane width are sufficient for all road users, including pedestrians and cyclists. Increased traffic also highlight issues in geometry and alignment, such as tight turns or blind spot, which can raise the risk of accidents. In short, understanding traffic volumes help identify this safety concern for further analysis.
For the apparatus, we use manual traffic counter, a stopwatch, safety vest, and safety cone. Next, procedure.
This traffic volume study was conducted at the intersection near HIS faculty over a period of 2 hours from 1 p.m. to 3 p.m. The video begins with a wide view of the junction to show the overall layout of the observation site. The first scene shows one group member using a manual traffic counter to record vehicles coming from the main gate direction, which is the main road. Next, I recorded right-turning vehicles from the minor road, which leads out of College Delima. In the final part, two of us work together. One continue counting vehicles from the same direction, while the other use a stopwatch to mark every 5-minute interval during the study. At each 5-minute interval, the number and type of vehicles were recorded according to their respective categories. Moving on to result and data analysis. This aerial image shows the actual layout of our intersections. There are 6 directions in total, labeled D1 to D6, and each was observed during our 2 hours traffic study from 1 p.m. to 3 p.m. Throughout the observation, a total of 1,620 vehicles were recorded. Based on the pie chart, cars accounted for about 64%, followed by motorcycle at 34.2%, while vans, lorries and buses made up the remaining percentage. To reflect the actual impact on traffic flow, we apply passenger car unit PCU value based on Arahan Teknik Jalan ATJ guidelines. Heavier vehicle like buses, lorries, carry higher PCU compared to motorcycles and cars, which car is only 1.0 and motorcycle is 0.75. After conversion, the total traffic volume was approximately 1,511.5 PCU for 2 hours, or 757.75 PCU per 1 hour. So this data gives a clear picture of traffic demand, vehicle composition and overall movement patterns at the intersection for further safety audit analysis.
Okay, next is the solution for the road safety problem. The first problem is speeding problem. The solution for this problem is by install speed bump at the intersection to reduce vehicle speed. Other solution is install speed limit to inform user of the maximum allowable speed. So the next problem is the alignment issue. The solution for this is road alignment improvement by smoothing the curve and correcting the sudden directional change. Second is grading adjustment by improve the slope at the intersection. The last solution is install convex mirror at the blind spot at the intersection. Next is the cross-section problem. The solution for this problem is by widen the road cross-section to ensure sufficient lane width and safer intersection as per Arahan Teknik Jalan 5/85. Okay, for the visual aid problem, we install the crosswalk signage to alert driver to pedestrian activity ahead, and we add the zebra crossing at pedestrian prone area to provide safe crossing point, and enhance road marking using reflective and high visibility material for better guidance. Okay, for the last problem is the street lighting problem. The solution for this problem is by regularly monitor and maintaining street lighting and repair any fault, as there has been a previous case of broken light causing poor visibility at this location. Thank you.